We're going to do some practice problems, and we're going to use these major rules. And again, I just want to point them out. We have the inverse relation here. We can express the exponential or as a logarithm. Then we have the change of base formula here. You can use either a natural log or you can use the log base 10, the common log. I'll do both. Then we have if a is equal to b, then you can take the logs of both sides. A is equal to b, it means the log of a is equal to the log of b, or you can do the natural log of a equal the natural log of b. And then we have the sort of the power rule that if we have log a x to the u, where u is some expression, you can bring that down, and that's what you get. And these are the problems, and so what I'm going to do is suggest that you work on those on your own. Pause things now, work on the problems, and then I'll go through the solutions. And I'll post the answer to each one before we do the solutions. That way you can see um, how things are working. And if you get the problem right, you can go to the next problem. Okay, so I'll see you in a bit. Okay, so problem one was to solve 3x equals 752. And the answer that I got was, let's have it back here, was x equal 6.028. Okay, 6.028. So if you got that right, go to the next problem. So I'm going to go through this. So what I'm going to do is I'm going to rewrite this as a log relationship, and that would be that log base 3 of the number is equal to the exponent. So I have x equals log base 3, 752. Now I'm going to write this in terms of natural log 752 over natural log of 3. I plug these things in, and I get 6.028. Okay, so that's number one. Number two is going to be very similar, except we have an expression, not just an x. That's not going to present any big difficulties. So I'm going to go through the same way. Rather than taking the log of both sides, I'm going to just rewrite the exponential relationship. That's going to be log base 4 of 99. The number is equal to the exponent that brought you that number. So I have 3x equaling log base 4 of 99. And then again, I have to go through the change of base. Oh, I didn't tell you what the answer was here. Sorry. Let me finish this, and I will. So this is going to be the natural log of 99. 3x is equal to natural log of 99 over the natural log of 4. So then I just have to divide each side by 3. And I get x is equal to 1/3, that 1/3, natural log 99 over natural log 4. And then the answer that I got for that was, let's see, I have it here somewhere. I can't find it. Sorry. I got 1.05. So I got this is equal to 1.05. So this is my x right here. So I want to circle that. And that was the x I got. I'm just going to go through the calculations, make sure I did it right. So let's go back here. So I'm going to clear everything. And looking at my paper, it's going to be 1/3 times natural log of 99 divided by the natural log of 4. Let's see what I got. I got 1. Oh, I didn't write it. I got 1.105. So I wrote it wrong. So let's go back so you can see what I wrote. I had the answer. I forgot the decimal place there. So that's the correct answer. So I'm sorry about that, and sorry to cause you some extra work there in finding that. Okay, so let's do the third problem. I'm going to use a different piece of paper. I'll actually just turn this one over. So the third one is going to be 5x equal 1/2. I'm going to do this by taking the logs of both sides, if that's okay. Just to do it a little bit differently. And okay. So let's see what I get. So I get natural log of 5x is the natural log of 1/2. Bring the exponent down. So I have x natural log of 5 equals natural log of 1/2. I have to divide each side by the natural log of 5. And so I get x is equal to natural log of 1/2 over natural log of 5. And let me see what I got for my answer. I did not do this. Oops, sorry about that. So I need to do this out, and I apologize. So we'll go back over here. We'll do it really quick. So this is going to be equal to the natural log of 1/2 divided by the natural log of 5. And what I get here is I get negative 0.4306, which rounds to 431. So again, we'll go back and look at that, and I apologize for not having the answer again. So that's a 4. So this is my x. Okay. So the fourth one, I do have the answer for this. And the fourth problem that I did is 5 times 10 to the t divided by 12,000. So that's a big number. Equals 5 halves. Okay. So the answer I got for this was a pretty big number. I got t is about equal to minus 3,612.36, and then I had rounding. Okay, so this is how I got that. I first divided both sides by 5. That cancels. So I get 10 to the t 1200 equals 1/2. Okay, so now I'm going to take the log 10 of both sides. I'm going to show you a trick. So log base 10 of 1/2. Okay. Bring the exponent down, so I have t 1200 log 10 equaling log 1/2. Now notice the log base 10 of 10, this is 1, so I can ignore that. That's just 1. Why? Because remember that the log base a of a is equal to 1, because a to the 1 is equal to a. Okay, so that makes it easier. So then I get t over 1200 equals log of 1/2, so I multiply. T is going to be multiply both sides by 12,000, multiply this by 12,000, cancels, so I get t is equal to the log of 1/2 times 12,000. And then I'm going to go over here, back, and work that out. So clear things. So I get 12, my answer is going to be 12,000 times natural log of, or, I'm sorry, regular log of, here, times the regular log, so I'm going to better hit that there, of 1/2. And notice what I get. I get minus 3612.3. That 9, the 359 will round to 0.30. Okay. So that's my t. And then I have one more to do. Okay. Again, the reason I just want to point something out, my trick was that knowing that I had base 10 here, I took the log base 10 of each side, knowing that I would get that cancellation right there. Sorry, let me go back. You didn't see what I just said. I forgot that I wasn't on my screen. So here's what I did. With this problem, which was this, I took the log base 10 of both sides because I knew I could get log 10 of base 10, which is equal to 1. And so that makes the work a lot easier. Okay, got one more to do, and then I'll say goodbye. Okay, so the fifth problem was 2,000, 1 plus 0.05 over 12 to the 12t equaling 4,000. Okay, now the answer that I got for that was t was equal to 14.469 years. 469, I didn't say what the context was. Now, this to me reminds me of an investment problem. I invest $2,000 as my investment. The interest rate is 5%, and I compound it monthly, 12 times a year. Okay, so that's what I get, and I want to find out when do I have $4,000. So when does it double? There's going to be a lot of problems like this. So I want to simplify this. So I'm going to divide both sides by 2,000. That cancels, and I get 1 plus 0.05 to the 12 over 12t is equal to 4,000 over 2,000, because I divided each side by 2,000, which is going to factor out to 2. Now I want to figure out what this is, so I'm going to go back and just compute it. So I'm going to clear everything, so I get 1 plus 0.05 divided by 12, and I get what I get for this. Sorry, I get 1.004. So let's go back. So this is going to be 1.004 to the 12t equals 2, which I find much easier. Okay, this base is going to be weird, so what I'm just going to do is I'm going to do the log of both sides things. This time I'll use the natural log. So I get the natural log of 1.004 to the 12t is equal to the natural log of 2. Okay, bring the 12t down, and I get 12t natural log of 1.004 equals natural log of 2. Now I have to divide each side by natural log of 1.004. So I get 12t is equal to the natural log of 2 over the natural log of 1.004. Now, I want to get rid of this number, the 12 in front, so I multiply both sides by 1 over 12. That cancels, and so I'm left with t equals log 2 divided by log 1.004 all times 1/12. And that should be this number that I got up here, the t equals, sorry, that will be this number here. The t equals 14.469. Okay, but let's see. Let's make sure we get it. So I'm going to go and compute that so you see where the number came from. Clear it, so I get natural log, so I'm going to get 1/12 times natural log of 2 divided by natural log of 1.004. That's my computation, and yes, that ends up being 14.469, which is what I got for my answer. So let's go back. So again, this is what I get. So we said it was 14.469, and that's my t value. That's my answer. Okay. So again, there's the whole problem. It's kind of messy, but if you can go through this and work through this, this is the math that we're going to see next week when we do investment problems, which we'll do a few of. Okay, that's it. Thank you.